Hi, this is your Professor Sudha Kolathuparambil, Section 10.1 Confidence Interval for the difference between two means independent samples. It has two objectives: distinguish between independent and paired samples and construct confidence interval for the difference between two population means. How can you tell whether a new drug reduces blood pressure better than an old one? Objective 1. Distinguish between independent and paired samples. A drug company has developed a new drug that is designed to reduce high blood pressure. The researchers wish to design a study to compare the effectiveness of the new drug to that of the old drug. We can design the study in two ways. One way is two samples of individuals are chosen. One sample is given the old drug and the other sample is given the new drug. After several months, the blood pressure of the members of both the samples are measured. We compare the blood pressure in the first sample to the blood pressure in the second sample to determine which drug is more effective. In this design, the samples are independent. This means the observation in one sample do not influence the observation in the another one. Another way of design is a single group of individuals is chosen. They are given the old drug for a month, then their blood pressures are measured. Then they switch to the new drug for a month, and after which their blood pressure is measured again. This produces two samples of measurement, first from the old drug and the second one from the new drug. We compare the blood pressure from the first sample to the blood pressure from the second sample to determine which drug is more effective. In this design, the samples are paired. Each observation in one sample can be paired with an observation in the second. In summary, two samples are independent if the observation in one sample do not influence the observation in the other. Two samples are paired if each observation in one sample can be paired with an observation in the other. Typically, the samples consist of pairs of measurements on the same individual or on pairs of individuals who are related, such as husbands and wife or brothers and sisters, like that. In this section, you will learn how to construct confidence interval from independent samples. Objective 2. Construct confidence interval for the difference between two population means. Imagine that we will compare the effectiveness of a new drug designed to reduce the blood pressure to the effectiveness of a standard drug. We will draw two independent samples. The first sample we will get the new drug. The second sample we will get the standard drug. We can imagine these samples as coming from two populations. A population of patients who take the new drug and a population of patients who take the standard drug. For each population, there is a mean reduction in blood pressure. We are interested in estimating the difference between the population means. Let mu1 be the population mean reduction for the new drug and mu2 be the population mean reduction for the standard drug. We wish to construct a confidence interval for the difference mu1 minus mu2. That is the difference between two population means. The point estimate for the difference between two population mean is the difference between sample means. Or in other words, we can say point estimate is x1 bar minus x2 bar, the difference between the sample means. Standard error of x1 bar minus x2 bar, the difference between the sample means. The sample means x1 bar and x2 bar have variance sigma 1 square divided by n1 and sigma 2 square divided by n2, where n1 square and n2 square are the population variances. When the samples are independent, the variance of the difference between x1 bar minus x2 bar, sigma 1 square divided by n1 plus sigma 2 square divided by n2. Standard error is the square root of the variance, so just take the square root of that. But we don't know sigma 1 square or sigma 2 square. We don't know the variance of the population. So we can approximate this with the sample variance S1 square and S2 square. So the standard error will become the square root of S1 square divided by N1 plus S2 square divided by N2. Critical value and margin of error. Critical value for confidence interval is T alpha over 2 based on the student T distribution. Degrees of freedom will be the smaller of N1 minus 1 and N2 minus 1. And margin of error is obtained by multiplying the critical value and the standard error. So we already find the standard error, multiply that with the critical value. The confidence interval is constructed by adding or subtracting the margin of error from the point estimate. So point estimate plus or minus the margin of error. So this will come here. This method is known as the Welch method. But it requires following assumption. It has three assumptions. We have a simple random sample from two populations. The samples are independent of one another. Each sample size is large and greater than 30 or its population is approximately normal. When the assumptions are satisfied, we can construct a confidence interval. Here assumption 3 is necessary to ensure that the sampling distributions of x1 bar and x2 bar are approximately normal because this justifies the use of students t distribution. So let me explain the formula again for the constructing the confidence interval for a difference between two means with independent samples. We are using the same procedure you learned in chapter 8. The confidence interval is point estimate plus or minus the margin of error. And margin of error is actually the critical value times the standard error. And degrees of freedom is the smaller of n minus 1 and n2 minus 1. So let's do an example on constructing the confidence interval for difference between two means. Example on constructing confidence interval for the difference between two population means. A drug company has developed a new drug that is designed to reduce the high blood pressure. They are taking a sample of 15 patients and giving the new drug, and it shows that their systolic blood pressure reduces by an average of 28.3 millimeters of mercury with a standard deviation of 12 millimeters of mercury. And they are taking another sample of 20 patients and giving them standard drug, and their blood pressure reduces by an average of 17.1 millimeters of mercury and standard deviation 9 millimeters of mercury. Assume that the blood pressure reductions are approximately normally distributed. Find a 95% confidence interval for the difference between the population mean reduction for the new drug and that of the standard drug. So the difference between population mean will be between these two values. Point estimate plus or minus the margin of error. I'm going to make a table with information for new drug and old drug. Sample mean, sample standard deviation, sample size and sample population, so that it will be easier to substitute into the formula. If you look at the formula, we already know x1 bar, x2 bar, those are here, okay, and we can substitute the variance for each one. We know n1 and n2, but we don't know this. So we need to find the critical value. So in order to find the critical value, we will use table A3 and the degrees of freedom. We will find the smallest of n1 minus 1 and n2 minus 1. So n1 is 15, so 15 minus 1 that is 14, 20 minus 1 that is 19. So take the smallest of that, so smallest will be 14. So degrees of freedom is 14. We will find the critical values. Degrees of freedom 14 and 95% confidence interval. It is given in the question. We will use table A3. 1 minus alpha is 0.95, that is 95% in decimal. So alpha is 1 minus 0.95, that is 0.05. So alpha over 2 will be 0.025. So in the table A3, degrees of freedom 14 and the column 0.025, find the intersection of those two, that is 2.145. Now we know all the information, we got the critical value also. So now substitute all these value and the critical value into the formula and construct the confidence interval. To check for assumption, we have two independent random samples and the populations are approximately normally distributed. Then we can continue the procedure. If you want, you can substitute everything at once and calculate, or you can do step by step procedure like calculate this first, then find this, then add and subtract. So I'm going to compute this step by step procedure. First, I'm computing the point estimate. So x1 bar minus x2 bar. Then find the margin of error, that is critical value times the standard error. Then construct the confidence interval. If you add these two, you will get the right bound, and if you subtract this, you will get the left bound. So the interval is, or the difference between the mean is between 3.3 and 19.1. Now we can interpret the result. We are 95% confident that the new drug provides a greater reduction in systolic blood pressure, and the improvement due to the new drug is between 3.3 and 19.1 millimeters of mercury. In this section, you learn the difference between the independent and paired sample and how to construct the confidence interval for the difference between two population means.